So yeah, good afternoon to everyone, and welcome to our first catching up session. With this session focusing on week 4 topics, especially proving algorithms. So yung pinakita ko dito before, yeah, I basically minodify ko siya a bit to be more uh, intuitive, I guess. So yung binigay kong parang 4-step process dito. Dinagdagan ko siya ng additional steps sa umpisa. And, ayan, so, you actually see it here. So, yeah. So, here's a summary of how you should go about proving your algorithms. So, ayan, dinagdag ko sa umpisa. First, you should determine the functionality of your algorithm. So, you don't have to be correct naman on your first try. Basically, pag nagkamali kayo dun sa functionality, parang check naman yon throughout your solution. So, parang may check and balance naman siya. So, ayun. To determine the functionality, usually gagawin mo, i-tabulate mo or visualize ano yung ginagawa ng function. And then, you use sample values to basically see anong ginagawa ng function. So, dun yung sa functionality. So next, of course, is yung proof termination. Medyo arbitrary naman to and pang sort of optional na. Pero if you want to be more formal, dinadagdag natin siya. And then number 3 is hypothesize a loop invariant. So before, ang ginamit kong term is determine a loop invariant. So I think ang better term is hypothesize a loop invariant kasi when we make a hypothesis, hindi tayo 100% sure na tama siya. Pero meron tayong pinagbasihan doon uh, sa pag-formulate sa kanya. So, parang inference, kumbaga, na may konting basihan and ayun. And yung pinaka-tip ko for making a loop invariant is by restating the functionality in its partially complete state. So, medyo sariling term ko lang yung partially complete. Papakita ko later anong ibig niyang sabihin. Pero, to have an idea, yung loop invariant mo should sound like yung functionality mo. And then, parang dinidecrease lang natin yung size niya. Makita niyo later kung ano ibig sabihin nun. Then, next is proving the loop invariant. So, actually, you can prove the loop invariant through direct proof. Pero since, because of its nature, pinakamadaling i-prove yung loop invariant by induction. So, of course, sa induction, meron tayong 2 steps. Or, I guess, yung 3 steps kung ika-count niyo yung termination. Pero, yung first step is determining the base case. So, to check yung base case, if consistent siya with the loop invariant, i-rewrite nyo lang siya using the initial conditions. Usually, I equals 0, the list is empty, etc. And usually, trivially true lang yung mga to. May magkaka-case na kailangan ng additional proving. But more or less, true na siya pagka-plug in mo pa lang nung initial conditions. So, next dyan is yung inductive step or yung tinatawag na maintenance in some sources. So, yung aking personal na parang operation or yung aking personal na steps na para gawin ito is first is rewrite the loop invariant using the next iteration values. Usually, ginagawa ko dito, sinasubscript ko ng new yung mga bagay-bagay. Makikita nyo to later. And then, after mong i-rewrite yung loop invariant, we prove this, yung rewritten na loop invariant by assuming that the original form ng loop invariant is true. And more often than not, you may need to use additional proving techniques or tinatawag natin mental gymnastics. And ayun, as long as consistent and may basis yung mga steps, most likely mapoprove mo na yung hypothesize mong loop invariant is true. Now, what if hindi mo siya ma-prove inductively or parang hindi mo ma-pag-agree yung mga statements mo? So, anong gagawin mo? Mali ka ba sa inductive step mo? Mali ka ba sa proof mo? Or mali yung hypothesis mo? So, what I suggest is, if absolutely sure kayo na wala kayong ginawang mali sa proof nyo, maybe mali nga yung loop invariant nyo. And kailangan nyo mag-reformulate. And if you're stuck naman, hindi mo alam kung mali ka sa loop invariant, kaya hindi mo siya ma-prove or hindi mo lang alam paano i-prove pero tama yung loop invariant mo. So that's the time when you have to ask. So, wag mo yung magtanong, especially since in this setting, medyo madali lang naman mag-resubmit and madali lang naman or we try our best to communicate online. So yun, once na-prove mo na yung loop invariant, punta ka naman sa termination value, which is parang opposite ng base case. Rewrite yung loop invariant using the termination conditions instead of the initial conditions. And then, because yung loop invariant natin, partially complete siya ng functionality, pag sinubstitute mo yung termination condition, supposedly at termination value, equal or equivalent statements yung loop invariant tsaka yung functionality. So, ano ba yung sinasabi kong partially complete na to? So, of course, the best way to show this is with an example. So, I have two examples here. One example is relatively madali, although hindi nyo masyadong ma-appreciate yung process kasi straightforward lang siya, which is actually kamukha noong sa week 4 na exercises. And then my other example is yung tinanggal na problem for the problem set. So, I guess mag-start muna ako dun sa madali. Just so that mas ma-highlight natin yung process instead of yung proof. So, in this example, we have a function called exponential generator or xgen. So, starting from an empty list, nag-append lang siya ng 10 raised to I, where I is in the range n, so 0 to n. So, determine the functionality. Parang medyo simple lang naman. Siyempre, at I equals 0, maglalagay ka ng 1. I equals 1, 10, and then 100, hanggang 10 to the n minus 1. So, a formal way of writing this is using set notation. So, x is equal to the set containing 10 to the k, wherein such that k is an element from 0 hanggang n minus 1. Kaya, functionality, basically gagawa lang siya ng list na starting from 0 hanggang 10 to the n minus 1. So, yun yung functionality niya. So, when this is actually asked, itong form na to would actually be alright. Okay na siya. Although, magandang ginagawa natin siya in this way para mas madali siyang improve later down the line kasi mas less words yung kailangan mo, more on symbols na lang yung gagamitin. So, yun yung functionality niya. So, yung termination naman, medyo trivial kasi basta for loop, magta-terminate naman siya in Python. So, okay na yun. So, next is hypothesize the loop invariant. So, ito na yung sinasabi kong restate the functionality as a partially completed state. So, before we go dun sa partially completed na state, ano ba yung completed na state dapat niya? So completed the state is yung at the end of the loop or at the end of the function, ano yung value ng x. So x is yung based sa functionality niya is x is the set of 10 to the k for all k na elements from 0 to n minus 1. So, ano yung partially completed na state nito? So, tingnan natin yung laman ni x per iteration ng loop. So, yung 0th iteration ni x, wala siyang laman. Yung first iteration ni x, 1 lang yung laman niya. Yung second iteration, 1 at saka 10. Yung third iteration, 1 hanggang 100. So, ang partially completed na state is instead of 10 to the k from 0 to n minus 1, yung dulo natin is hanggang I minus 1 lang. So instead, yeah, wala yung I minus 1. Yeah, may I minus 1 dapat. Hanggang I minus 1. So, ito na yung tinitingnan natin, or ito na yung i-hypothesize natin, loop invariant. So, yeah. X is the set of 10 to the k such that k is in 0 to I minus 1. So, partially complete siya kasi yung complete state natin is NC hanggang N si X. Pero sa loop invariant, I lang siya. Kasi we want the loop invariant to be true for each iteration ng loop. And yung functionality will only be true at the end of the loop. So, pag complete na siya, doon pala magiging true yung functionality. Pero at intermediate steps, ito yung magiging true. And makita nyo kung yung proof naman nito is medyo straightforward. So, proving the loop invariant. So, yung base case, initially I is equal to 0. So, rewrite lang natin yung loop invariant. So, 10 to the k, k is 0 to 0 minus 0 hanggang 0 minus 1 or negative 1, which is technically an empty set. So, is empty. So, yung initial value ng x natin dito as defined dun sa ating function is an empty list as well. So, by yung base case natin is true. Or the loop invariant, assuming the base case is true. So, next naman yung inductive step. So, need natin i-prove si x 10 to the k such that k is an element. Now, instead of I minus 1, lalagyan natin ng subscript na mu, si I minus 1. Kasi sa inductive step, tinitingnan natin yung value ng loop or yung value ng ating loop invariant at the new iteration or the next iteration. So, baka gamitin ko yung new at saka yung next interchangeably for this. So, in this case, new yung gamit ko. So, ayun, we have to prove this statement assuming na yung loop invariant natin by itself is true. So, walang changes dun sa loop invariant. We assume that it is true. So, ayun, rewrite ko lang. We have to prove this one. And then, because of the nature of the for loop, we know that yung new na I is just yung incremented na original I. So, I new is equal to I plus 1. So, i-replace lang natin yung nandito sa statement na to. Yung I plus 1, ipalit natin kay I new over here. So, kailangan na natin i-prove na x contains 10 to the k, wherein k is 0 hanggang I. So, using our assumption, alam naman na natin na x already contains 10 to the k hanggang k equals I minus 1. So, kailangan na lang natin i-prove na x contains 10 to the I. And medyo trivial lang yung proof kasi yung command na to, x append 10 raised to the I, yun exactly ginagawa. Yun, once this executes, we are sure na 10 to the I, yun nasa loob nung ina-append natin, is napapasok kay x. So, na-append si 10 to the I kay x. So, parang medyo parang common sense lang. Since in-append natin si 10 to the I kay x, x already contains 10 to the I. Therefore, we prove that the loop invariant is true for the inductive step. So, given yung command na to, and this assumption, we have proven that x contains 10 to the k, where k is from 0 to the new value of I minus 1. So, okay na tayo sa base case, okay na tayo sa inductive step. Therefore, the loop invariant has been proven true. So, okay na sa loop invariant. So, determine what happens at termination. So, at termination, I equals n. So, yung last na value ni I will be n. So, kailan siya n, kailan siya n minus 1. So, depende siya sa pinaka standard mo, pinaka reference mo. Ako kasi, kung titingnan nyo yung sa proof, yung bagong I is I plus 1. So, at the last iteration ng loop, I will be n minus 1. So, yung huling value ni I new will be n. So, n minus 1 plus 1. Kaya, ang ginamit ko dito is at termination, I equals n. So, you can parang consider this as yung last value ni I will be n. And apparently, actually, nasa labas na siya ng loop. And that's alright. Because at termination, yun nga, I last is equal to n. And if we rewrite the loop invariant, or this one, so si I, gagawin ko lang n, may kita ko yung functionality ko. So, because of how we wrote yung loop invariant natin, pagdating natin sa termination value, parang sure na tayo na termination value is equal or equivalent dun sa functionality. So, exactly the functionality. So, hopefully in this example, nakita nyo na from yung functionality, paano natin nakuha yung loop invariant. So, basically, nagpalit lang si n to I. And honestly, for most loop invariants, yun lang yung kwento niya. Gagawin mo lang I si n. Pero, that's not always true. Especially if hindi list yung ginagamit dun sa function, which is where this next example comes in. Ayan. So, generic common function. So, ito yung function na nandun sa problem set part 2 na tinanggal na. Since actually medyo hindi siya ganun straightforward. So, since masyadong mahaba yung generic common function, sinulat ko na lang yung initials or yung acronym niya, GCF, which gives you an idea kung anong ginagawa actually ng function. So, ayun. First step is determine the functionality. So, we visualize it with sample values. So, try natin. What is the GCF with A equals 56 and B equals 35? So, at the 0th iteration, or yung initial conditions, si x equal kay A, si y equal kay B. So, si x 56, si y 35. And then, itong x new at saka yung y new will be yung value ni x and y at the end of the loop. So, at the end of the loop, si x magiging y. Si x magiging y. So, yung bagong x is equal lang siya dun sa y. And then, si y naman, si y new, will be x modulo y. So, ano yung modulo operation, siya yung remainder pagka divide ko sila. So 56 over 35 will just be 1 point something. So kukunin lang natin yung whole value. So kukunin natin pala yung remainder rather, which is 21. So yun yung remainder when we divide 56 and 35. So sa next iteration, yung x new at saka y new, sila na si x and y. So, and yung bagong value ni x new after the first, after iteration 1, x new is 21, and then yung modulo or yung remainder, pag divide ko si 35 with 21, is 14. Then sa next iteration, ganun pa rin, 21 and 14 mapupunta lang sa x and y. Yung bagong new, yung bagong x is 14, yung bagong y is 7. And then sa next iteration, 14 and 7. So si x new ay maging 7 and yung y new is 0 kasi wala na silang remainder. And since yung loop natin continues as long as y is non-zero and naging 0 na si y, si x new or si 7, siya na yung final value na i-return natin sa return ng function natin. So as you can see here, 7 is interestingly yung greatest common factor ni 56 at ni 35. So, si 56 ay 7 times 8, si 35 ay 7 times 5. So, kung skeptical pa kayo, kung GCF nga siya, let's try it with other values. So, let's try it with 32 and 15. So, pag 32 and 15, remainder nila is 2. And then 15 and 2, yung x nyo ko is would be 2. And then yung remainder ng 15 divided by 2 is 1. And then 2 divided by 1, walang remainder. So 0 si y new and si x new is 1. So tama naman, GCF ni 32 at 15 ay 1. So with that, sige, kahit hindi pa tayo sure, at least kung wala ka naman di ba maisip, siguro yun na muna, tentatively. So the functionality, we find the GCF of A and B. So next will be yung proof of termination. So dito hindi siya as straightforward as kanina. We have to evaluate anong nagiging value ni y. So y always becomes x modulo y. And then you can actually say x modulo y is always less than y. Kasi if yung remainder ko would be y, then ibig sabihin, wala dapat siya remainder, so 0. So always less than y yung result ng modulo operation. So y is strictly decreasing. And if y is strictly decreasing, starting from a positive value, eventually aabot din dapat siya kay 0. So that will be our proof of termination. So what would be our loop invariant? So kailangan natin i-restate yung functionality as its partially completed na state. So yung completed na state natin is x is the GCF of A and B. So paano kaya natin makukuha yung partially completed state nito? So we can look at, again, of course, yung itsura ng iterations natin. And if papansinin mo, sa x and y, kung i-compare mo sila, you can actually say na yung GCF ng lahat ng numbers na naging x and y is yung GCF din ni A and B. So yung greatest common factor ni 35 and 21 is also 7. Ang greatest common factor ni 21 at 14 is also 7. So maybe yung partially completed state, ayan, ano ginawa ko dito? So instead of nire-state ko lang, ginawa ko lang equal sign, tapos ginawa ko lang shorthand yung GCF. So yung partially completed state natin is the GCF of x and y at any point dun sa loop is also the GCF of A and B. And sabi ko nga dito, you don't have to be sure as of now. And yun nga, yun yung dahilan kung bakit natin ipoprove yung loop invariant. So at this point, we have reason to believe na yung GCF ni x and y at each iteration ng loop is also the GCF of A and B or yung original na inputs. So yun yung ilalagay natin as our loop invariant. So next step is to prove the loop invariant. So ayun, the base case. So initially x is equal to A and then y is equal to B as stated by our function over here. So if we rewrite the loop invariant, so x and y siya originally, since si x equal kay A, tapos si y equal kay B, ito yung magiging itsura ng first left-hand side ng loop invariant. And yung right-hand side ng loop invariant stays the same. And yun, so two same statements. So by the reflexive property of equality, a function is equal to itself. And you know, trivially, pero it's, we know that it's true. So next would be the inductive step. So dito na tayo medyo kailangan ng mag-isip-isip. So we rewrite the loop invariant using yung new na subscripts. So instead of x and y, x new at saka y new. And we have to prove this statement assuming that this statement is true. Ayan. So, rewrite ko lang ulit. So, yung focus tayo dun sa kailangan natin i-prove. So, ang first step is, ayun, para lang ginawa kong math mode lahat para mas madaling i-type. So, first, we let G be equal to the GCF of A and B. So, basically, nilasign ko lang siya sa variable. So, we can rewrite x, since yung GCF ni x and y ay G as well, we can rewrite it as G times some constant, Cx, and Cy as some constant times G. G times some constant, Cy. And then, one thing to note over here is that Cx and Cy should be relatively prime, or wala na silang common factors kasi yung greatest common factor nila is G. So this statement is actually important later on. So kailangan siya i-point out dyan. Next, we say that x is equal to k times y plus x modulo y. So bakit? So pag dinivide ko si x with y, yung result niya will be some whole number na integer and yung remainder which is x modulo y, tama? Divided by y. So if i-multiply ko ng y both sides, makukuha ko na x is equal to some whole number times y plus x modulo y. So pwede rin naman na case na k will be 0. So x will just be x modulo y. So ayan. So clear naman siguro paano nakuha itong equation na to. And ayan, given this equation, we actually want to isolate x modulo y kasi siya yung statement natin for the bagong value y. So, ililipat ko lang si k times y sa right-hand side. So, may minus kxy, k times y. And then, so ito yon. So, nilipat ko si k times y sa right-hand side. So, our equation now reads x modulo y is equal to g times cx minus k times y. Now, si y, di ba, sinulat natin siya or pwede natin siyang i-express as g times cy. So, yun lang din ang ginagawa dito. And then, we can factor out yung g term, this sa first term here, And this is second term. So x modulo y, we can actually say is g times cx minus k times cy. So let's put this to the side. Galing. And ayun, let's just state that x nu will be y, and that will be equal to g times cy. So yun pa yun kanina pa from the start. And then yung bagong y nu, will be x modulo y, which is yung kaka-expand lang natin as g times cx minus k times cy. So, hopefully nakasunod pa kayo. After nito, ayun. So, basically, replace ko lang yung x nyo at saka y nyo with g times cy and g times cx minus k times cy. So, nireplace ko lang siya dito. And, of course, note that yung mga c at saka k natin, lahat sila positive integers. So, yung term na to, we expect it to be an integer as well. So, something to note lang din before continuing. So, ayun, we have shown na may common factor sila na g, yung dalawang terms natin. But, ayun, we have to prove that it's the greatest common factor, which means that si cy and si cx minus k times cy should be relatively prime or wala silang common factors na iba pa. So, in order to prove that, is actually mahirap siyang i-prove directly. So, we're gonna use contradiction. So, by contradiction, we want to prove the opposite. Kailangan, we want to prove that if cx minus k times cy and cy have a common factor f, then there would be a contradiction. So, ayun. So, assuming the reverse is meron silang common factor f na pag kinuha natin yung modulo, maging 0 yung result. By this assumption, ayun. So, yun. Pakapakita lang natin na may contradiction with this. So, yung modulo operation, we can actually distribute this to its contents. So, cx modulo f minus k modulo f times cy modulo f, all modulo f. So, property lang talaga yan ng modulo operation na pwede mo siya i-distribute over addition, subtraction, and multiplication actually. Although, pagka-distribute mo sa kanya, yung term sa labas, actually hindi mawawala. Pero, you'll see why this would be useful. And, ayun, mapapansin nyo, meron tayong cy modulo f na term here. And because of our assumption na cy, f is a factor of cy, thus wala siyang remainder, cy modulo f should be 0. So, gagawin siya 0. And ito, kahit anong man value ni k modulo f, multiply natin sa 0, should be 0. So, in this case, cx modulo f should be 0. However, remember yung statement natin kanina, since we know, ayan nga, if napakita natin na cx modulo f and cy modulo f equals 0, edi ibig sabihin si f, common factor din siya ni cx and ni cy. However, nasabi natin at the start, cx and cy are relatively prime. Wala dapat silang common factors. So, we have a contradiction. Therefore, this cannot be true. So, which means that we have proven na walang common factors si cx minus k times cy and cy, and therefore they are relatively prime. So, I will pause to let that sink in. So, since if we assume na may common factor yung dalawang terms na to, Cx and Cy would also have a common factor as well. And that cannot be the case. Kasi yun yung ating part yun ng ating inductive assumption. Saan ba yun? Cx and Cy should be relatively prime. Kasi G is the greatest common factor. Therefore, Cx and Cy should be relatively prime. So, since nakakita tayo ng contradiction, since nakakita tayong contradiction, we have proven that these two terms should be relatively prime. And therefore, ang GCF nitong term na to is actually G. Actually, kulang pala. So, we have to prove that this is equal to G. So, G will be the greatest common factor kasi Cy and this term over here are relatively prime and both are multiplied to G. Therefore, G is greatest common factor. So, we have proven that the loop invariant is true in the inductive step. And therefore, by induction, we have proven that the loop invariant is true. And then, ayun, just finishing up, at termination, x modulo y would be equal to 0. And that would mean the GCF of x and y should be equal to y. So, pag si x dinivide ko by y tapos walang remainder, ibig sabihin si y is a common factor. Therefore, ang greatest common factor ni x and y would be y. And based dun sa ating function, yung last value ni x would be y. So, yung values ni x and y na magiging 0 yung remainder pag dinivide ko would be si y yung greatest common factor, and then that would be yung value ng last value ni x. And then yun yung in-return natin as the value of the function. So, ayun. Hopefully na-gets nyo. And hopefully I was able to see or I was able to show paano ginagawa yung process. Of course, this is my personal take on the process and medyo curated siya for our course wherein yung mga examples or yung mga activities natin, medyo knowing these things are actually enough. So of course, pagdating sa future courses, mas magiging generic yung mga generalization. So itong summary na to is medyo specific pa siya for EEE 121 since hindi rin tayo ganun ka-formal sa proving. So nakita nyo kanina how we restate the functionality with its partially complete state given yung kanyang functionality na complete state. And then napakita rin natin na in the inductive step or when proving the loop invariant, gumamit tayo ng iba pang proving methods such as contradiction para lang ma-prove yung inductive step. So yeah, that will be all for this session.